This podcast deals with the Logger Pro software program dealing with linear graphing. In today's episode, what we'll take a look at is how to set up your X and your Y variables. We'll take a look at the auto scale feature as well as the linear fit feature. So the first thing we'll do is we'll start off with the X-axis. You have to determine what is your independent variable. You'll double click on this, and double clicking on the X allows you to type in the term that you wish to use. In this case, we will have time. So we'll put time here, and it has a short term. So instead of the X, we will put time here as well. The units we'll use are seconds. So we'll have that. Once we have those three put into place, we'll hit the done. And you'll notice up here it says time, and it also has the units. Under the Y axis, what we'll take a look at are let's do distance, or actually let's do position change. Now that's going to be rather long, so we'll just simply put in position here, and the units will be in meters. When we're done, go ahead and hit the done. You'll notice here it says position, and that was the shortened term. If we actually extend this out, you'll notice it says position change, but in the meantime it's just shortened itself to position. So you'll notice down here, so that's the first thing that we're taking a look at, is how to set up the data set. On the graph, you'll notice that it shows on the y-axis is position change, which is measured in meters. If we go back here to position change, we don't want to put the units directly in the name, because what that does is that considers its name, not the units. So we'll take that part out, and we'll click done. So we have position change measured in meters. Time is measured in seconds. Now if you messed up on your data set, all you have to do is left click, and you can actually set time and on the y-axis, and we can change it to position change on the x if we really wanted to do that. But you can just change them back and forth by left clicking and doing that. So we'll put in under time, we'll do 0 seconds. We'll just simply make it pretty easy, and we'll do 8 seconds worth of data. We'll start off with 1.2 meters. We'll do 2.3 meters, 3.6 meters, 4.7 meters, 5.9 meters, 7.2 meters, and let's see, 8.4 meters, 9.7 meters, and we'll just do 12.0 meters. Really have an outlier out there. So you'll notice that as we entered all of this data, the graph itself was realigning itself, readjusting itself in order to get all the data on the graph. If we change this now and just put in 11, you'll notice that it drops back down a little bit, and now it looks pretty linear. So that's the first thing. We entered in the data. We put all that in. Now, if we had put something out of place, let's say that we'll put 5 down here at the bottom and 7.2, but let's go up here and say 9, and let's put 12.2. So you'll notice that it still graphs the information up here. We have our 9 value and the 12.2, but it just doesn't look that well. So what we can do is we can right click on it, and we can do sort data. And we can say which one we want to sort it by. Let's sort it by time. So we'll sort it by time, and you'll notice that the 5 and the 9 have changed. So that's just simply right clicking up at the top and then going to sort data and data set, and then you can change that. So it puts all of the variables back, or puts all the data back in order. So the second thing we're going to take a look at is the auto scale feature. So we have this nice graph over here on the right side, and we hit this A button at the top. This A button is the auto scale graph. So when we click it, it's actually going to take the graph information and shorten it down. So you have the very first piece of data here on the left, the very last piece of data on the right. One thing we always want to do is make sure that we have the origin. So we'll go to the x-axis, and of course we left click right where the 0 is, and it says 0, so that's good. Now we move up here right by where the 0, or the bottom of the graph is, and we're going to put in, it says 1 here, let's go ahead and put 0 in, and you'll notice that it's now adjusted it. So we have the origin back in where we started. So that's the second thing, is using this auto scale button up at the top and then making sure that we put the origin back in. Now the third thing is that this is a linear graph, and we'll use this R value up at the top. So by hitting this R value, you'll notice that it has this spot right here. It doesn't really give us much information. Somehow we got stuck on this line here. So what we'll do is we'll hit this X button. That will delete it. And then we'll left click somewhere on the graph, and you'll notice that the line has disappeared. This time when we hit the R button, it'll give us the graph, this bracket over here on the left hand side, and the brackets on the right hand side. Everything in between the bracket and the ket is data that it's measuring. And so we get this idea that it's 1.229 meters per second. So, and that's the slope. That's the benefit of putting in these units here where it says meters and seconds. This change in, or the slope, is the change in y over the change in x. So it's going to be meters over seconds. So meters per second. And so we have a slope of 1.229 meters per second. And then it also gives us the y-intercept, which is our b value. If you remember the equation, y equals mx plus b. And that tells us that basically our slope-intercept, or our b value, is 1.089 meters, which if you take a look over here at the very beginning, which was 1.2 meters, it's very close. And this, of course, is our line of best fit. And you'll notice that most of the data is pretty close. This right here is our podcast on linearizing a graph, or a linear graph.